Right, this is a limiting reagent kind of problem, and in all of these instances we've always got an amount of a reactant reacting with an amount of another reactant. Now even though these amounts look the same, 100.0 grams of each, we actually have different amounts because we have to take into account moles, and we also have to take into account the moles used of each in the reaction equation. So what we're going to do is we're going to come up with what's called a mole ratio, and that mole ratio takes into account the number of moles and the number of moles in the reaction equation in each cases. Whichever one comes out with the smallest mole ratio, that's going to be our limiting reagent. Alright, so we'll start out with 100.0 grams of NaHCO3, and we know that we're after moles of that first, so we'll put grams of NaHCO3 on the bottom to cancel up the top. We'll have moles on top here, and we know that 1 mole is equal to 84.01 grams of molecular weight. In the next step, we want to take this number of moles and essentially divide it by the number of moles in the reaction equation. Now, dividing is the same as multiplying by 1 over whatever you're dividing by, which is 3 moles of NaHCO3. So this sometimes confuses folks because they see a 1 here and no unit. Really all I'm doing is I'm taking this number of moles and dividing by 3 moles of NaHCO3. The 3 comes from up here because we know we get 3 moles of this in the reaction that needs to react. So we've got this moles divided by these 3 moles, and that's going to give us something that doesn't have any units associated with it. A mole ratio of 0.3968 is what this comes out to. Alright, so now we'll do the same to the other one. We've got 100.0 grams of H3PO4 times, and then we've got 1 mole. We'll do grams of H3PO4 first, and we'll put moles of H3PO4 on the bottom. And the relationship here is that 1 mole of H3PO4 is equal to 98.00 grams of H3PO4. We get that from up here. Alright, so times 1 and then a line, and we're going to divide this by the number of moles in the reaction, which is 1 mole of H3PO4. This gives us 1.020 as our mole ratio. Now since this one has the smaller mole ratio, that means that the NaHCO3 is going to be the limiting reagent here. Alright, just to give you a little bit more context here, and I'll give you my cheese sandwich analogy. So let's say you want to make a cheese sandwich. You'd use 2 bread plus 1 cheese is equal to 1 sandwich. It's a pretty boring sandwich, but that's the way it goes. So if you had, say, 10 slices of bread and 6 cheese, the question is, how many cheese sandwiches could you make? And I'm hoping you can see that you could only make 5 cheese sandwiches. Now the reason we know that is because 10 bread would make 5 sandwiches, and 6 cheese would make 6 sandwiches. But since we don't have enough bread for 6 sandwiches, all we can do is make 5 sandwiches. If you take a close look at what we did though, we took the 10 and divided by 2 to get the number of possible sandwiches we can make. That's the rationale for dividing by the number of moles in the reaction equation in both of these instances. It's telling us how much of something we can get if we take into account the number of moles used in each instance.